I'm Anil Kumar, and here is a very good example on derivative of exponential functions. The question is, show that the tangent to the graph of f of x equals to e to the power of x over 1 plus e to the power of x is non-negative. Determine the equation of the tangent to the curve at y-intercept, right? So there are basically two parts to this question. First, we'll find the derivative and show that the derivative is always non-negative, means positive. It could be 0. Now the second part is determine the equation of tangent to the curve at y-intercept. So y-intercept is at x equals to 0. Let us find the y-intercept first, right? So what is y-intercept? So y-intercept is at x equals to 0. That means f of 0, right? So what is f of 0? So we'll substitute 0 here. So we have e to the power of 0 over 1 plus e to the power of 0. Anything to the power of 0 is 1. So we have 1 over 1 plus 1, that is half. So y-intercept is at 0 half, correct? So that is the y-intercept for us. So we'll say y-intercept is having the coordinate points of 0 and half, right? That is y-intercept. Now, let us find the derivative of the function. So we have the function f of x equals to e to the power of x divided by 1 plus e to the power of x. So the derivative of this function will apply the quotient rule, right? So that means denominator square, so which is 1 plus e to the power of x whole square, derivative of the numerator, which is same, times 1 plus e to the power of x minus numerator times derivative of denominator, which is e to the power of x. So that is what you get. Now this could be written as, we could write e to the power of x common. So let me write e to the power of x common. So what I get here is 1 plus e to the power of x, 1 plus e to the power of x, and on this side we get minus e to the power of x, right? Divided by 1 plus e to the power of x whole square, right? Now in this, e to the power of x minus e to the power of x is 0, so we are left with 1 times e to the power of x. So therefore I can write down my derivative as e to the power of x divided by 1 plus e to the power of x whole square, right? So that is the derivative of the function. Now in this derivative, what do you notice? E to the power of x is always positive, denominator is always positive, right? So this derivative is always, I should say, greater than 0, right? When x is very, very large, right, since this degree is higher, then it approaches 0, right? So it approaches 0 when x is very, very large, but it is non-negative. So what we see here is that the derivative is non-negative, right? So that is what we observe. Now, second part is determine the equation of tangent to the curve at y-intercept. Now to find the tangent, let's find the derivative of the tangent at x equals to 0. So that is to say, let us find what is the derivative at 0 itself, right? At x equals to 0. If I substitute 0 here, what do I get? So I get e to the power of 0 over 1 plus e to the power of 0 whole square, and that is 1 over, this is 2, right? So 2 square, and that is 1 over 4. So the derivative is 1 over 4. So what is the equation of tangent line? So let's find the equation of tangent line, right? So now we'll find equation of tangent, and what we have here is a point. Let's say point is y-intercept, which is 0 and half, and we also know slope is 1 over 4, right? So that is what is known to us, and therefore we can write this equation as y equals to slope of 1 over 4 x plus b. To find b, we will substitute the point itself, which is 0 and half. So half for y equals to 1 over 4 times 0 plus b. Obviously this is y-intercept, so half equals to be the y-intercept. So therefore we can write down the equation, I could have written earlier also, as y equals to 1 over 4x, correct? Plus half, which is the y-intercept, right? So that is how we could write the equation in slope intercept form. So now we get solution. So we'll say answer is y equals to 1 over 4x plus half. Now some of you can also write this in standard form. Multiply everything by 4, bring them together on the left side with x as a positive coefficient, right? So if you do that, if you multiply by 4, what do you get? Let me squeeze it in here. So if I multiply by 4, this will be just x, right? Okay. This will be 4y, bringing it to the right side minus 4y, and we have plus 2 equals to 0. So that could be the equation in standard form. I hope this helps you to understand how to find equation of tangent line at a given point for exponential functions. Thank you and all the best.